Hi and welcome. So, recursion. We are going to talk about recursion. We are going to simplify recursion. Have you ever thought about recursion in depth? Do you feel recursion is really hard? क्या आपको भी recursion से डर लगता है? या recursion समझ में नहीं आती? Or do you feel the logic building of recursion is not easy at all? Means कैसे सोचो recursion का logic? क्या होता है आखिर function calling itself? ये जो definition है recursion की इसका मतलब क्या है? So I am going to discuss and I am going to really simplify recursion for you in this particular video and in the subsequent videos. So I hope you will like this particular video. If you have ever faced issue in recursion, if you ever felt like recursion is hard, after this particular video and subsequent videos, you will not feel like that. I will make it really simple for you. Fine. So let's start with it. So before we move forward, do not forget to hit the subscribe button and click on the bell icon. Okay. So let's get started with recursion. The definition of recursion is function calling itself. We are going to see nothing in this particular video but just this one line. What is the actual meaning of function calling itself? What is happening inside of it? Okay, then we will discuss about what is base conditions and how to think of the recursion questions and everything else after this. Because understanding this particular point is very important, that what is the meaning of function calling itself. So for that, I have taken a very simple example. I have a function which is returning nothing. It is taking n as a parameter. If n value is 0, then in that particular case, we are returning, okay, no value, we are just return because the function is returning nothing. Then we print n. Then we call the same function with a value of n minus 1. So that is function calling itself. The function calling itself. Fine. With a same value or with a different value. Okay, so we are calling a function with n minus 1 value. After this particular part is over, we are again printing n. So, but what is actually happening? Let's see inside of it. So, whenever a function calls another function, okay, whenever there is a function call, okay, so suppose there is a function call from point in some main function, okay, here I have called some function, fine. So whatever this function is called, whenever this function is called and it returns, whether it returns the value or does not return a value, it returns to the main function back, or it returns to the calling function back, it returns to the exact same point. Fine. So if in the fifth line of the main function or any function, I have called a function called sum. Fine. So whenever the sum function is over, it will always return to the same line. It will always return any value, or if it is not returning any value, it will always return, okay, the execution will start from again the fifth line. Fine. So first important point. Fine. The next important point is whenever a function is called, a separate memory is created. We call it stack memory. Fine. So that is what I have created here. These are separate memories. So whenever I will call this function, a separate memory will be created. Fine. Now let's suppose I call this function with a value of 5. Okay. So in this particular part, n value will become 5. Fine. Now step by step, let's try to solve this. This is the first line, this is the second line, this is the third line, and this is the fourth line. Fine. So in the first line, the first line will get executed, that if n equal to 0 return. What is the value of n in this particular function call? So let's say this is the first function call. In the first function call, what is the value of n? It is nothing but 5. Fine. So will the first line will get executed, that if n equal to 0 return? Obviously no, the first line will not get executed because n equal to 0 is false. Okay, that means it will check whether n equal to 0 or not, but it will not return anything because the if condition is false. Second line, yes, obviously print is a normal print line, so yes, it will get successfully executed, print n, and we will print 5. Fine. What is the third part? Third part is function calling itself. Now this is a function call. Function call with n minus 1. Okay, so n minus 1. What is the value of n? 5. 5 minus 1, 4. So it will call the function with a value 4. That is the another function call. So second. Fine. Here n value is 4. Now again the same point will occur because it is calling the same function. So again the first line will be checked, the second line, the third line, the fourth line, and so on. Fine. So from this point we have called another function. That is the same function in recursion. So in the first line will not get executed, means it will be false. N equals to 4, it is false. Second line, yes, it will be, we will print 4. so 4 gets printed. Fine. Third line, obviously it is a normal function call, so we'll call the function with the value 3. Now from this point another function is being called, so value 3, that is the third function. Fine. N value is 3 here, n minus 1 is 3. Fine. First line false, second line print function, normally print method, so it will print 3. Fine. Third line calling another function with a value 2. Fine. So here now in the fourth stack, in the fourth memory, we'll have n value as 2. First line will not get executed, means it will be false. Second line we will print it out, so we'll print 2. And the third line will simply call the function with a value 1, because n minus 1 is 1 here. So this is the fifth function call. N value here is 1. First line will not get executed, second line will be printing 1, so 5 4 3 2 1 we are printing in reverse here. Third line will get function call with a value 0. Now as soon as we go to the sixth stack, we found out that n value is what? 0. So what will happen? Just think about it. What will happen when n value is 0? So when n value is 0, this first line executes successfully. Okay, if n equal to 0, return. So now we have our keyword return. So we'll return. Where we will return? We will return to its calling point. Always function returns to its calling point. What was the calling point for the sixth stack? The calling point for the sixth stack was this particular third line of the fifth stack. You can see on the screen as well. Fine. So this was my calling point. And the execution now will start in the fifth stack after the third line. So is there anything after the third line? If there is nothing after this third line, we'll return to the calling point of the fifth stack. Okay, but there is, we have the fourth line as well. So fourth line is nothing but print n. So now tell me, what is the value of n? So what is the value of n in this particular stack? That is important. What is the value of n in this stack? The value of n in this stack is nothing but n equals to 1. So 1 will get printed. 1 gets printed. After the fourth line, is there anything else in this function? No, it is not. So it will return where? It will return to its calling point. So return to its calling point in the fourth stack with the third line and execute the fourth line of the fourth stack, which is nothing but print the value of n. What is the value of n in the fourth memory cell? It is nothing but n equals to 2. So we'll print 2. And we'll return after this to the calling point of the fourth stack, which is nothing but the third line of the third stack. Fine. After this, execute the fourth line here, print n. What is print n? What is the value of n in this stack? The value of n in this stack is 3. Similarly, it will return here and it will print n of the second stack with the value 2, with the value 4, and it will return to the first stack, which will print the value 5. So the output will be 5 4 3 2 1 1 2 3 4 5. The main thing here to understand in recursion is whenever a function calls itself, it will execute that function in a separate memory cell. Okay, the variable values will be there according to whatever we have passed, whatever it is being updated. Fine, that value will be passed. Fine, then whenever we will return to the calling point. If there is any other line, if any other code is remaining to be executed, it will get executed like normal. Fine, and if there is no other point to be executed, no other statement to be executed, then it will simply return back, fine, to the previous calling point, and it gets solved like this. And it stops because of something called base condition, which we are going to discuss in the next video. But in this particular video, I really wanted to focus on this one line, that is, what is recursion? Recursion means function. Everyone says recursion means function calling itself. So this is what function calling itself is. This is how a function calls itself and gets executed, and how returns work. Fine. So this is what you need to understand. You need to practice. This is also called tracing of recursion or dry run of recursion. Take some small examples and try to dry run those examples on some test cases, fine, like this, to understand recursion in its depth. I hope you like this particular video. Please, if you like this video, do comment what you want next. Fine. Subscribe to our channel. Share this particular video with your batchmates, with your friends, and I will bring out more videos on recursion to simplify it for you. Fine. I hope you liked it. Bye bye. Adios.